It's me again. I'm here to talk more about electronics and I2C. I did a video a while back and everybody was kind of asking for more description and a project that they can actually duplicate. And so here goes, because I'm building something for myself, so I figured I'd stop and take a little bit of time to record the process of how I got to where I want to go. What I'm demonstrating here is an EZB3 board using I2C. I haven't tested it on the EZB4, but I don't see why it wouldn't work. And what I've got is I've got it connected to the Arduino using the I2C port of the Arduino to the EZB. Now, connected to the Arduino, I have an ultrasonic ping sensor. Right now, that's the only thing I have connected. So in phase one, my goal was to get it so that from the EZB, I can, over the I2C, request from the Arduino the data, and that the Arduino send back to me what the distance was in that ping. Okay, so I've done that. Here you're seeing in the video is the layout of the board I have and the working setup I have. This is the Arduino chip. I'm going to hit start over here. You can see I have a script set up, and it's very simple. Let me show you. I'm just printing I2C read, and I'm reading 6 characters. So I'll just say go. And when I do, you see D1 equals 21. If I come here and I move that sensor closer to the wall, and let's do it again, and now well, it's seeing something else over here that's 4 inches away from it. So there we go. We're back to 26. Let me put that back. Now we're 4 inches away. I'm dividing on the break. My goal here is to actually have more information, and I'll show you what I'm talking about there in a second. So basically, this is how it works. I'm going to post the Arduino code. It's very small. I'll post it in the article that I attach this to. But I wanted to show you what my ultimate goal is. So this is phase one. I'll post this up, so anybody attempting to do this, I'd be glad to help you with what you need to do it with. But this is my ultimate goal. I took some plastic, some of that Molder's plastic, and I made me a little 4-way, move my camera up. I made a little 4-way sensor. And so my goal is I want to embed one of these little chips in here and just have my power ground, like a little chip like this, embedded inside of here, then make a little standard jack that I can plug this into my robot project. I specifically made this exactly this size because it will pop up and out of a Pringles can. And so that's kind of my goal, that this thing can pop up, rotate 1/4, so it doesn't need continuous rotation servo. It can just move 1/4 and then give me a radar map of 360 degrees around me. So like I said, right now, one step at a time, we're going to get this all working, which it does. So now I'm going to move on to wiring this puppy up to the chip. Then phase 3 is going to go just one little step further, and I'm going to take this temperature reader and apply it also, so that in one device I can ping that. Whenever I ask for a request, it's going to take 4 readings for distance, and it can be up to you to determine whether this is front, back. They come back as D1. That's why up here on the screen you can see I got D1 equals 4 inches. Well, let me measure it now. It should be about 20 something, 26. Okay, so D1 equals 26. The second one in line is going to be D2, D3, D4. You get the idea. Then the temperature, I want it to come back with a T. I'm going to divide everything with colons in the Arduino code, so that all I have to do is split this stuff by colon, and then I can separate my information and use it in my application. I hope that was chilling for you guys, and it worked out to be some help. I'd be happy to help anybody that needs it, so just let me know, and I'm out of here. phase 2 coming up real soon. I'm going to have this working. It's going to be bionic. Check back soon.